Ну, мы продолжаем доклады. Наталья Андреенкова с докладом «Разработка морфометрической формулы для полевого определения пола птенцов степного орла в Altai-Sayanском регионе».
Dear colleagues, I will not talk about poisoning. I want to tell you about the morphometric formula that will help determine the sex of steppe eagle nestlings based on the simple measurements of some parts of their body. The steppe eagle shows sexual dimorphism in size, but size ranges of females and males overlap greatly. And most accurate way for sexing, of course, is DNA analysis. But sometimes it's important to know the sex of the nestling when you are directly on a nest. For example, tagging the bird with GPS transmitters and something like that. And it's impossible to use laboratory diagnostics right near the nest. Experienced ornithologists can quite accurately determine the sex by eye, but this doesn't always work, and not all researchers have sufficient experience. That's why we tried to get a formula just to calculate the sex. We took a sample of 52 steppe eagle nestlings from Altai-Sayan region, and we used 15 measurements. Length of feathers on wing and tail, length and diameter of tarsus, length of claws, and different measurements of the beak. To get a formula, we needed to know exactly the sex of each nestling. While we measured nestlings, we took a samples of genetic material, a small feather from the body, and then we determined the sex in the laboratory genetically using helicase gene CHD1. This gene is located on the both avian sex chromosomes Z and W, and have different intron lengths. So we can quite simply determine the sex by PCR when we get one band. So it's a male with two identical Z chromosomes, and if we get two bands, it's a female with Z and W chromosomes. Once we know exactly the sex of each nestling, we can look at distribution of different traits in males and females. Here, for example, tail lengths and the median values don't differ significantly, and the same pictures is for wing feathers. But it's a big depth, and medians are different significantly, but values overlap greatly, and it's pretty the same picture for most traits: length of tarsus, claws, and beak. But here is the longitudinal tarsus diameter, and medians differ significantly, and the most of values didn't overlap, but part of values still overlap. Yes. And now look at the correlation of different traits. The different measurements form clusters of high correlation inside, and this is a cluster of feather lengths on wing and tails. It's quite expected that they are strongly correlated, since all the nestlings feathers grow very fast. Here are lengths of claws, and so all 4 claws grow quite synchronously, and this lengths of beak from forehead, nostrils, and cere. And they are, of course, they are correlated. But what correlate with sex? Feather length least correlated. It's clear because of all nesting were of different age, and all were on stage of intensive feather growth. So the length of feathers depend on age too much, and against this background, we couldn't detect differences between males and females, even if the differences exist. And tarsus diameters, transverse and longitudinal, most strongly correlate with sex. And at the same time, they have a little correlation with other measurements. And that is the tarsus weight isn't really dependent on beak or claws. And it seems that this trait, tarsus diameters, can be used to determine the sex in the first place. Here is dependence of the first tarsus diameter on the second. Males and females form two clouds, and that overlap a little, but they do overlap. So taking only tarsus diameters isn't enough to for sexing. So we have to use some other body sizes. And to select additional traits which can help us, we need to use a discriminant analysis. To begin with, we found the measurements which that contribute most to separation of males and females, and we got 9 measurements. And of course, the first place are 2 tarsus diameters. And based on these variables, we got a classification function, and it works like this. You should multiply these values by these coefficients, sum it all up, adding this constant, and if the result is less than -1, it's a female. If it's more than 1, it's a male. But if the result is between -1 and 1, classification is considered unreliable. And this formula made one mistake for our sample. So we decided to try different things to improve the classification. To begin with, we excluded redundant variables from each clusters. Redundant variables which highly correlated with others and so don't contain useful information. We removed one variable from close cluster and big cluster, and in feathers cluster we left only tail length because of they are all highly correlated. And in addition, since we are using nestlings of different ages and different sizes, we decided to apply age normalization. That is to use not only pure measurements, but also ratios of variables. Because most of variables are correlated, their ratios must be less dependent on age. Therefore, we took the pure measurements, add their ratios to each other, and so we already had 66 variables and repeated our discriminant analysis for all of them. And we obtained another variables that contribute most to separation and another formula. Then we tried to remove more redundant variables, and also we tried to remove all feather lengths because of they have a little correlation with sex, but surprisingly that formula worked worse. So for some reason the tail lengths still improve sexing. And after all these things, we got more than 20 different formulas, but even if they work well on the training sample, it doesn't mean that they will work well with another new nestling. So we test our formulas, used 2 independent testing samples. The first one was collected in 2021 and the second in 2022. But we tested these samples separately since this year was abnormal due to a severe shortage of food. A lot of nestlings died, and the survivors were small, thin, and had not enough body fat due to chronic underfeeding. And we tested all our many formulas on these test samples. But here I shown just 4 most promising formulas. We can see how many mistakes did make each formula for each sample. And all these formulas work pretty well with training sample and with this test sample, but they make a lot of mistakes with these rachitics. And in this sample, there are 13 nestlings that are misclassified by at least one of these 4 formulas, and they are all females. So half of females were identified incorrectly. Apparently, due to underdevelopment of muscles and bones, and due to lack of body fat, the tarsus of females were too thin, and such females were classified as males. And so we had to repeat discriminant analysis separately for these 42 nestlings to identify the traits that contribute most to separation of males and females. And on the first place was a longitudinal tarsus diameter, not the transverse one as were for normal nestlings. Apparently, the longitudinal diameter depends less on body fat amount. And as before, we added the ratios and tried to different sets of variables and chose 2 formulas that worked best. And here are the results for different formulas, how many mistakes they make for normal nestlings for 2 years and for these rachitics. These 3 formulas were obtained for normal nestlings, and they work with normal nestlings well, but they make a lot of mistakes on rachitics. And this formula were obtained for a sample of 2022, and they work quite well with rachitics, but they make a lot of mistakes with normal nestlings. And notice that we cannot yet test these formulas because we have not another independent sample of underfed nestlings, so we don't know if these formulas will work well with new rachitics. And these 2 bottom formulas were obtained earlier in another study using fewer measurements. The close lens wasn't used at all, and it used an average tarsus diameter instead of longitudinal and transverse diameters. And the results were not very good back then, so we decided to use more parameters, and we can see now that the separation here is better, much better than it was there. And here's the best of our formulas. Since they give a bit different results, they can be used simultaneously to confirm the results. And if nestling is of normal fatness, then we should trust these formulas. But if they contradict each other, and if the nestling is underfed, small and thin, then we should look at here. But remember that they have not been tested on independent sample. The easiest way is, of course, to take an Excel table, write down the formulas, and just put the values, and program will immediately calculate all 5 formulas. But since we used samples from Altai-Sayan population, our formula may not be suitable for sexing in another steppe eagle population. It would be interesting to test the formula in more western steppe eagles. That's all, and I'd like to thank Igor Koryakin and Lena Schneider, who measured all nestlings and collected samples for genetic sexing. And then we, with Maria Shalnova, determined the sex and genetically, and did all the statistics. Thank you for your attention.
Я посмею задать вопрос, но вопрос, наверное, Игорю, который замерял, делал замеры. Существуют ли какие-то рекомендации по проведению измерений цевки? Ну, насколько я знаю, вот Бjörn Хеллендер в Швеции замеряет цевку у орланов, она неоперенная, он мне объяснял, он делает легкое касание штангенциркулем, не продавливая кожу, эпителий. А у орлов цевка оперена, и это вызывает трудность в замерах.
Ну да, если нет опыта измерения цевки у орлов, можно накосячить, да, но мы всегда стараемся измерять, либо подняв перья, вот, чтобы измерение было на коже. Ну и тут надо, как говорится, набить руку, чтобы не продавливать сильно кожу, когда цевка жирная. Вот, либо прощупав пальцами оперение, ну, в общем, сдавить так, чтобы не продавливать кожу. Но это, в общем, когда ты меряешь там десяток другой орлов, это видно. Но лучше, конечно, если перья у взрослых птиц вот они достаточно отросли уже, их просто вот так вот поднять и измерить.
Спасибо.
Ну, поэтому, если это публиковать, то нужно, конечно, очень четко
Вот
написать, как это измерять.
вопрос такой. Вот параметры, которые измеряли, в частности, длина цевки, длина хвоста, она в гораздо большей степени зависит от возраста птенца, чем от половой принадлежности. Вот как вы решали эту проблему с возрастом?
Ну, в общем, я примерно и сказала, как мы решали эту проблему. Мы попытались использовать отношения величин друг к другу. Но на самом деле, то есть поскольку вот анализ нам выдал, да, вот эту формулу, которая в принципе работает, ну, для птенцов вот данного возраста, то значит она работает. Но да, мы применяли именно отношения одного измерения к другому, потому что, ну, они все коррелируют, да, и по идее отношения должны меньше зависеть от возраста, чем сами вот измерения.
Слышно меня, да? На самом деле, многие параметры, когда птенец растет, они же синхронны, то есть у него клюв, когти, хвост и крылья достаточно синхронно. Поэтому, конечно, если мы берем в измерение там птенцов 40 и 60-дневного возраста, нам длина хвоста, длина крыла ничего не даст по половому различию. Нам нужны соотношения именно хвоста к клюву, там, крыла к когтям.
Но тем не менее цевка была без отношения, то есть она была, ну, то есть она давала наибольший вклад не в отношениях, а именно вот как чистое измерение. То есть цевка не особенно растет уже в этом возрасте, видимо.
Ну да, соответственно, учитывая, что мы уже мерили птенцов, которые начинали оперяться после 30 дней, то цевка, вот как оказалось, она практически не растет у них в этом возрасте уже. Именно ширина цевки. Они только набирают жир, и она становится толще за счет вот набирания подкожного жира.
Okay, thanks. I wondered if you'd use the foot span measurement. We found it really effective for golden eagles, along with weight from about 5 weeks. It's kind of over 95, 98% effective. And it's also starting to be used on Egyptian vultures, and the results are looking really promising at the moment.
Ну хорошо.
Но это пролет лапы, то есть когда лапа раскрыта,
мы
меряется.
просто не брали,
да. Мы начали мерить последнее время, но мы просто пока не анализировали.